All right, so page 3, we already talked about the top part. All right, so let's look at example 4. So 4, we have our linear differential equation, second order, y double prime plus 2y prime minus 24y equals. Then over here on the right, we have 16 minus x plus 2e to the 4x. So there's our g of x. We're going to kind of break that down into two different g of x's because it's separated by that difference, and I'm going to show you exactly how we're going to do that. But first, let's find the complementary solution. So we set our differential equation, put them in the form of m, set equal to 0, solve for the homogeneous part, and we get y sub c is equal to c sub 1 e to the 4x plus c sub 2 e to the negative 6x. All right. You always want to solve for the complementary part first because you could have repeated values, and there's no way that you want to solve for y, your particular solution, and find out, oh, it was a repeated one, and I have to do all that over again. I have to take the derivative over and over and over again, plug it in, and solve. You don't want to do that. All right, so let's solve for this differential equation. So here, notice, oh, we have an e to the 4x. All right, so I'm glad that I solved for the complementary because I have that there. So just know that I have that. All right, so when I look at this, all right, 16's part, so we're going to make that our first part of the particular solution. That's why it's y sub p sub 1. That's going to be a because it's just a constant. Now, minus x plus 2 e to the 4x. I'm not really going to worry about the minus sign, so don't freak out about that. So I have a linear times an exponential. So I'm going to set it up this way. Bx plus c e to the 4x. Now, one thing that you might want to do is set that up, and there you have it in the particular form. We just combine all those together. Over here to the right, we notice that if I distribute, so let me just show you if I distribute everything. You don't have to, but if I distribute everything, I get bx e to the 4x plus c e to the 4x. So that's my y sub p, all right? And I notice, oh, this is already accounted for right there. So I need to make that an x. But I already have an x here. Well, then let's just put that one up 1. And so now I have everything accounted for. All right? So, you can say, oh, I want to multiply by... you're going to have to multiply this thing by... You're going to have to add an x in there. And so it would be like, bx squared cx on the inside. And then solve. And so you distribute, and that's what we're going to be working with. So we want to make sure that we have that added x in there. All right? So even though, this would have gave us a new one, we had to realize that but adding that c in there would have gave us something that we already have. So and then we just multiply this whole thing by x because we need to go one step above, and that's how we're going to get the bx squared plus c. All right, let's go ahead and erase these by hand because I wrote too much stuff. All right, so here's our particular solution. Let's go ahead now and take the derivative of that. Again, you can choose which method you can, So here, let me go ahead and write this in there. So you could, take the derivative of, this one or this one, whatever one you want to, work with first. Sometimes people think it's easier to work with, all the parts spread out or work parts together. It's up to you. You're going to get the same thing if you do it right. Take the derivative. We get the derivative there. All right. Then take the derivative of that, and you get this long bad boy, which is fun. All right. And then we're going to combine our like terms to give us that second order or second differential equation. All right. Now we're going to go ahead and plug everything in. So that's fun, plugging in all those long derivatives. So all of this is y double prime, all of this is y prime, and all of this is y. All right, so you can see that up there where everything's coming in. This is set equal to this. All right, I didn't have enough room to write that, but know that, hey, that's right over there on the right-hand side. Now, it's just algebra, which this is what really stinks about this class. What we did is not hard, but it is very easy to make a mistake because there's so much there. So you have to be careful, all right? So, again, you pause this, look at this, all right? I combined all my, so here's everything multiplied out. I'll go ahead and, I cancel some things out. So like what I do is, what you would probably want to do is start over here and notice, usually this is going to stay because the a had already, that's the only a that you have. But this minus 24bx squared e to the 4x will probably cancel out. And it does. There's an 8, and then there's a 16, so that cancels out. Minus 24cx e to the 4x, is that going to cancel out? Let's see. We have a plus cx e to the 4x. Do I have any more? Oh, there it is, and it cancels out. So everything that I've just highlighted cancels out. Everything that I'm about to highlight remains. So I have 16. That's going to combine with this 4. That's how I get 20 bx e to the 4x. This 2b e to the x, and this, oh, that's the only one. 8c e to the 4x is going to combine with 2, and then minus 24a. So, hey, we got everything. All right, so it's a good idea to mark things on your paper. Again, hopefully you have something like I do. That way you kind of can keep everything in order and then just get rid of it like I am doing right now. All right, and now we set that equal to the right-hand side. Find the coefficients that correspond. So we're looking for things with e to the 4x. Well, things with e to the 4x are going to be this 10 and this 2b, or 10c, I'm sorry. So we're going to put those together, set that with the e to the 4x. We have an e to the 4x, e to the 4x. All right, do I have anything with x e to the 4x? Yes. That's going to, so I'm going to go ahead and write that by itself. All right. Whoa. I don't know how that happened, but there's no 20. There should be a 20 here. All right. So hopefully you watch to this end. All right. And then let's get back to the highlighter. So I have that 20b4x right there. And then I have my constant. There's my constant. So I want to set all those equal to each other. I'm going to have to put it back in. How did you go away on me? All right. So we set our coefficients equal to one another. So again, all those come from these coefficients over there matched up with the corresponding, functions part, the x parts. And then we solve. This first one is easy. And the a and the b are easy. And then the middle one's easy too because you got to substitute in for b, negative 120. You're going to get, for c, negative 19 over 100. Substitute in. Here's our complementary solution, and here is our particular solution. And we're all finished. All right, again, you can check to see if this is a solution. How can you check? You can plug this into your differential equation on the left and see if you get that on the right-hand side. All right? And again, I know some of you are going to do that. Why? Because you want to make sure that you're correct, and that's great. So do it. If you're overconfident in yourself, you're finished, all right?